This is Expert Funda and you are watching on YouTube. So today we are going to see the today Leetcode question that is we have is 427 construct quad tree. Okay, so we have a n cross n matrix we have given that is called grid, right, of zeros and ones we have given. Okay, in the matrix we want to represent the grid with a quad tree, that we will see what is the quad tree. So we have to return the root of the quad tree that representing the grid. Okay, so notice that you can assign the value of node to true or false when is leaf is false, right? Is leaf is false, then we have to assign a value of a node as a true or false if the is leaf is false, and both are accepted in the answer, right? Either true or false if the is leaf is false, right? And both are accepted in the answer, correct? So a quad tree is a data structure. Now understand the quad tree, right? So the quad tree is a data structure, tree data structure, in which each internal node had exactly four children, right? So previously, if you remember, you have gone through binary, right? So in the binary, what happened? We have a root tree, right? This is, let's suppose this is our root tree, right? So there will be a left child and there is another right child, right? So in this case, now it will have four children like this, like C1, C2, C3, and this is C4. Okay, exactly four children should be there. That is called quad tree. Besides each node had two attributes. Besides each node has two attributes, that is val and isleaf. So the value is true if the node represent a grid oneness or false. If this is oneness or false, means the value should be true. And if the node represent grid of 0, and if the node represents 0, means it is saying we have value will be true if the node represent oneness, right? If value will be true, value will be true if it represent grid value is oneness, right? And it will be false, right? This will be false if grid value is 0. Is leaf is true if the node is node leaf is leaf of the tree node, right? Then we have to say this leaf node is true, right? And then we have to assign. Otherwise, if has four children we have, right, false, we have assigned. If the node has four children, then we have to assign false. If it is a leaf node, then we have to say it's true. Okay, so the class, if we will represent this node, right, for the quad tree, right? So if we'll take a class, right, so it should be the first val and is leaf. So if it is 0, then we will assign true, and if it is ones, then we assign val as a false, right? uh, is leaf is right, we will assign true if it is a leaf node, and if have four children, then we will assign false. Otherwise there will be four nodes, you can say four children nodes will be there. So C1, C2, C3, C4, four children are there. So C1 is top left, top right, bottom right, and bottom left, right? The bottom right, you can say. So because this is grid, right, so we have to represent into grid, right, like this. So we'll see this one exactly. So as you can see, if there is four children is there, see, this is the one node we have, another node we have, this is also a node, and this is also a node, right? So this is the top left, top right, bottom right, and bottom left. Okay, these four nodes we have. So we want to construct a quad tree, right? And we want to form two-dimensional array, right? We can construct a quad tree from a two-dimensional area using the following step. The first is what? If the current grid has the same value, if it is 1s or 0s, or we set is leaf true, right? Means if the current grid has same value. Okay, if current grid has same value, then what we will do, we will set is leaf is a true, means this is the leaf value. Okay, and it will set value to the value of the grid and set the 4 children as a null, right? And we will stop there, right? So what we will do first, we will how we will construct the quad tree. So first we have to do, if we will check if the current grid has the same value, then like either 1s or 0s, right? If all is 1s or all is 0s, right, means we have to set that is leaf is true, means this is leafed children. Okay, and we will set the value val of the value of the grid as a, there is a 4 children, right? So we will add null to them and then we will stop. Next, it is saying that we will do if the current grid has different values, right? If it is like 1s and 0s, it is in the mixed form. Okay, so the is leaf is false, right? Because this is not the leaf children, right? And we have to set the value, any value, and divide the current grid into 4 subgrid, as we have seen here, as we can see in this photo, right? And then recurse for each of the children with the proper subgrid. Okay, then we have to do the recursion for each of the children with the proper subgrid, right? Understood? First we will check like if all have like 0 0 0 0, right, like this, then means we have to set these current grid has the same value. If the current grid has same value, either 0 0 or it will be maybe 1 1, you can say 1 1, like this, then what we will do, we will say is leaf is true, right? Is leaf is true, and the value will be set as a null for all the children, and then we will stop. Okay, if the current grid has like some value will be there like 0 1 1 0, like this, there is mixed value, right? Then what we will do, we'll say that is leaf is now false, right? And what we will do then what we will do, then we will set value equal to we will set value equal to any value, and we will divide the current grid, we'll divide this current grid into 4 subtree. So 1 subtree, 2 subtree, 3 subtree, 4 subtree we'll do like this, and we'll say we will divide the sub into subgrid like this we have, right? In this we have, and then we will do the recursion for these 4 children. These 4 children we will do similarly for this for these 4, right? We will do this one. Okay, because we have each children we have, right? This is 1 children, this is for 1 children, this is for 1 children, this is for 1. So each children with the proper subgrid we have, and for that we have to recurse the same thing as step 1 and step 2, we have to do that, right? Like there can be a 0 1 0 1, there can be 0 0 0 0, there can be 1 1 1 1, right? So that we have to do recursion for the third step, you can say. So this step is also done. Now if you want to know more about the quad tree, you can refer to the Wikipedia that you can see here, right? Or I think you have understood, then fine. Let's do to understand the saying that what is quad tree format, right? So let's understand the quad tree format. Okay, so the output represent the serialized format of a quad tree, right? And using the level order traversal. Okay, using the level order traversal, I think you already know about the level traversal. What is level order traversal? Let's suppose this is root, this is children, right? Let's suppose this is 1 2 3, and another we have what, 4 5, let's suppose we have. So this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. So this is level 1, and this is level 2, and this is level 3. So this is called level, right? So it is saying the level order traversal we will do, where null assign a path terminator, null assign a path terminator where no node exists. Okay, if there is no node, right, then what we will do, we'll say this is null, right? This is null, this is null. Okay, we'll do that, and that is a path terminator, means we have to terminate the path, right? Now it's very similar to serialization of a binary tree, right? uh, so if you are aware of the serialization of binary tree, then it is very similar to that. If not, you can do Google and you will understand. If you like to do some hands-on on there, you can ping me in the comment box to make serialization of the binary tree. I'll do that. Now think about the next statement. The only difference is that node is represented as a list, you can say, is leaf and val, right? So only difference is that the node is represented as a leaf, as a list, you can say, with is leaf and val, right, like that. So if you have already aware with the serialization binary tree, so it is saying that only difference between only difference between that is that node is represented as a list, right? Like the node contains isLeaf and value as a list. Now next step is saying that if the value of the isLeaf or val is true, right, we represent as 1 in the list, right? And if the value of the leaf and val is false, we represent as 0, correct? So you understand? So is leaf is true or val is loop, either any of these two, like is leaf or value is true, means we will represent as 1, or not, then we will put 0. Let's understand this example 1, right, so that it will clear a concept. So we have given a grid, right, that contains 0 1 0 1 1 and 0, right? So if you represent into the grid, it will look like 0 1 1 0. So output saying that we will make what, 0 1 1 0 1 1 1 1 1 0. So how will it work? So let's understand these explanations so will you understand. Notice that 0 represent false, right, and 1 represent true. Okay, so in the quad representation, okay, so we have 0 1 1 0, right, we have given. So is leaf is 0, right, first it is saying is leaf is 0. So val is 1, right? So what we will do, we will take top left, top right, bottom left, bottom right, right, that we have already seen here, this one, right? Top left, this is top left, top right, top bottom, bottom left and bottom right. Okay, so for top left, right, for top left, what we will do, we'll check is this 0 or 1, right? So first we have what, we have 0, so we'll say if this is 0, so leaf is what, 1, because this is leaf is 1 and value is 0, right? Now we will say top right is what, top right is we have value is 1, so this is leaf, right? So we'll say 1 means false. Again we'll see for the bottom left, that is 1 and bottom right is 0. So we have represented like this. Okay, now what we will do, it will put into our as a list, right? So this is, we have to store this one into list, you can say. So first is coming what, value, we have to represent into what, see, we have to take isleaf and val, right, isleaf and val. So that what will do, what we will say that we will add this value, right? Okay, sorry here. So what we will do here, we'll put first what, 0 1 1 0, right, and then what will come, 1 1 and 1 1. So these four value we have what, can say 0 1, then we have this last one bottom right, right, that is called 1 0 1 0, right? Then what is coming, 1 1 and 1 1 1 1 and 1 1. And if you'll see that this value is in the output one, correct, and that's why it is coming like this. I think we have understood, right? So let's understand uh, the next example. Now example 2 we have given, it's very vast, right? So this is the representation we have, this is the input grid we have, and we are getting this output grid. So what is saying that all value in the grid are not same, right? And we divide the grid into 4 sub grid. So how we'll do that? So if this is 0 1 2 3 4 5 6 7, right, means 0 to 8 we have, so we have to divide like this, we have to go like this, and then we will divide this one, right? So this will become, this 4 we have become like this one, and this is top left, top right, top bottom left, bottom right, like this 4 we have. So it's saying top left, top bottom left, these are the have the same, right? So this is same and this is same, right, we have. Now if and this is also same, right, 3 we have same, only difference is this one we have different, right? So what is saying that the top right, that is this one we are saying, talking about this one. So top right have different values, so we divide into 4. So if we'll divide this one, so it will become what like this. Okay, it will become 0 0 0 0 and then 0 0 0 0, right? Again it will become 1 1 1 1 1 1 1 1. So this will become what, equal, you can say. So this will become our this is the grid we are talking about, right? So what happened, there are four grid we have four, and each have the same one. So this is same, this is same, this is same, this is same, right? So that if we will re-represent this one, it will look like this one. Okay, and so that first we have is leaf, right? And the top left is what we have, leaf is 1, value is 1, right? Now second what we have is leaf is 0 and 1, right? Then we have what, value is 1 and this one is 0. Like this three we have, this is 1 1, and this is our, this is also same, right? So you can say this value, and the last one is different, right? This is different. Okay, so that we will take value is 1 and 0. Then what we will do, this is there, this is here. Okay, now what we will do, so now we will re-represent this one into four parts. The first this part, it is coming like this. So what we have, leaf, this leaf is what, this is value is 0, right? Here value, next what we have, this one, and this value is what, 0, value is 1 from here, and here value is 1, right? Like this we are getting. So if we will re-represent this one, it will become what, 0 1 1 0 1 1 in the last, and 1 1, and similarly we'll get this value from here like this only. Okay, so you will get this answer as a output, right? So first we'll get 0 1 1 1 1 0 1 1, and rest of the we are getting what, we are not going to the next level. We have to terminate with null, right? And similarly we'll get these values, right? For this one, for this one, right? We are terminating this one, so we are getting these values. Okay, now we'll think about okay, now constant is giving that grid length is what, equal to n, and equal to its length, right? Means number of rows and columns are same, you can say. Now it is saying that n equal to 2 to the power x, where x is greater than equal to 0 to 6, right? So this topic is related to array, divide and conquer, you can say, tree, and you can say matrix. This is related, and this question has been asked in multiple times in the interview, right? So I'll suggest that you should focus on this problem, because see, the problem sentence is very lengthy, right? Sometimes you will feel that this is not easy, and uh, this is very lengthy, this question will not get answered into the interview room, but you should try and you should have the hands on here. So the question, this question has asked multiple times, and maybe asked in the any other further interview. Okay, so let's see the approach, right? So the first approach what we will do here is recursive. Okay, so the first, you what you have to understand that we have given we have a what square matrix we have given, right? That is, we can say n cross n, as we have given here, or x cross y, you can say. And our value can be either zeros, and either one, either there will be 0 or 1. So we need to convert this matrix to you can say a quad tree, and with nodes having two attributes, either the value or is leaf, right? So we always see there is a is leaf is there, and there is another is value is there, right? So the first it was saying that three approaches we have to do, right? You can say steps we have to do. If the whole matrix has the same value, either it is value is either 0 or 1, right? If all is 0 or all is 1, then what we will do, we'll say is leaf should be what, true, and value would be same as the matrix value, either it will be 0 or either it will be 1, right? And then we can return the values, right? Now it is saying that if this is not the case, if it's different, either it will be mixed with 0 and 1, right? So what we will do, so it's not a leaf node. First we'll check if otherwise we'll check what, if it's not a leaf node, right? So is leaf would be either, is leaf should be now false, right? It should be now false, correct? And the value will not matter, right? This node will have 4 children, because, right? So what we will do, we will divide that, and we will divide into the next matrix, you can say, right? And we'll check again the values are same or not, that we have seen already, right? So and the next what we should do, we will divide the current matrix into four equally sized quad matrix, right? and then we will recurse the same process to each level, right? We'll do the same things, right, as we have seen here, right? This one, what we will see, we have seen that this is same, this is same, this is same, but this part is not same, right? So what we have done, we have again divided this one, right? So now it will become same, 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 so we have a stop there. If this is not same, so we will divide again, right? Like that we will do. So this process we have to follow again and again. Okay, so only what we have to see, if this is equal, this is same, right? The whole matrix has the same value, either 0 or 1, then what we will do is leaf would be true, and value would be what, same as the matrix value, and we will return that. And if not, right, otherwise what we will do, if its leaf node is not leaf node, right, then what we will do, we'll say is leaf is false, right, and value will not matter, because there will be node have the 4 children, right, 4 children nodes. And then what we will do, we will divide the current matrix into 4 equally size you can say square matrix, and then we will recurse the same process each time. Now what we will do, now we will check the process, right. So what we will do, the possible way to divide the matrix into 4 parts, we'll do later, we'll understand later. So what we can see in this problem, right, in the problem explanation, you can say the matrix is repeatedly dividing 4 times, right, 4 subparts again and again, right? So it we can suggest that we will use a recursive approach, right, to divide the current matrix into 4 parts, and then again and again we will repeat the same division on a smaller parts recursively, you can say. And we will discuss 2 recursive approaches to solve this problem, right? So that's why that's why we should take the approach is recursive, right? So what is our intuition, you can say, for the recursive is we are doing multiple time divide, right? Because the same process only to check the value is it is same, if not same, then we will divide this one, right? So the most intuitive way of solving the recursive problems, like uh, this is the way, right, we perform what the problem description says and just follow the same recursive approach, right? So before we start the process, we need a way to define the current state of you can say our matrix to generate the state from it, you can say. So as we have discussed, right, the matrix is square, and we can re-represent, you can say, by 2 coordinates such as top left and bottom right, right? So this is our top left and this is our bottom right. So this would be correct, right? This would be become correct. For simplifying, we can say, you can say we will use only top left, right, and you can say we'll check coordinates with the another variable. We'll take some variable x y z, anything, you can take length also, right? And we will check and which we will the sides of the square, you can say. Using these 2 pieces of the information, we can find any corner coordinates of the square, right? So what we will do, uh, the steps for making the quad tree in the problem description perform the same with the code, right? The first one says that if the matrix coordinate is only 0, right, or 1, then we can return, right? And what we have to do, what we have to do, notice that this is the base condition, right? If there is all is right 0 or 1, then what we will do, we will return, we will not do anything. So we can simply check all the values of the current matrix state, right? And if it's all the values are same, right, we will simply return the node with the specified attribute whatever we have. So if not, then we will return then we need to divide the matrix into 4 parts, right? Sorry. And what we will do, we will follow the process for each of the 4 separately nodes, and then we would become 4 children nodes. So the 4 matrix would have the top left you can say coordinate as we can see here, right? And each of them would have the length of the same side, right? What we'll do, length by 2 we'll do that, and there we will call a recursive function for each submatrix, right, and then we will assign the return nodes as a child of the root node we will return. Okay, so as you can see, we have taken this is the matrix we have, right, in the red color you can see, right, and there is 4 units we have, right. The first is here, top left, top right, bottom right, this like this we have taken, right. Now what we will do after divide, if the value are same, then we will if values are same, then what we will do, we will if different, right, then what we will do, we will divide and we'll check separately each of this one. We have already knows this one, right. So what we will do, to do this one, first we will iterate all the values in the current matrix, and from the top left we'll start from the top left, and with the top left coordinate, this is, we can say, x1 and y1 will start, right, and the length of the side will take, and if all values are same, then we'll create and return a leaf node with the same value. We will not do anything, we'll create and return from here. If the values are not same, we'll create a new root, right, a node root you can say. We'll make recursive call to the 4 matrices, right. We'll do that. Then we will do what, we'll divide this one and we'll check first for this one, if this is same, this is same, this is same, this is same, right. We'll do recursive call for all of them. So for the top left, for this top left, what we will do, we'll take top left coordinate as x1 and y1, and for the top right matrix, right, what we will do, we'll take x1 and whatever the value we have, y1, and whatever the length we have, here length is 4, because see 0 1 2 3 4, okay, 0 1 2 3, so it is 4, right. So we'll do length by 2, we'll divide from here to here, and we'll do we'll add here. So total length is what, 8 we have, so we'll add length by 2. This is the total length we have, L. So if L is there, the L by 2 will do that. Okay, so this is our L by 2. So L is what, we have 8 here, right. Now what we will do, first similarly we'll check, we'll do this x1 plus L by 2, and x1 plus y, for x1 plus L by 2 and y1 plus L by 2, will do that, and we will assign the node. This recursive call will assign to the child node of the root, and then we will return our root node, you can say. So this process will follow. So let's see the problem, right, and so we'll do the solution, we'll do the coding in the browser section, and let's see the approach. Okay, so this is, we have given the quad tree node, right, and quad tree node we have already seen that we have two things. The node contains value is leaf, and the another 4 values we have is top left, right, top right, bottom left, and bottom right, right. These things we have given, and to initialize this we have 3 different constructor. One is the default constructor, and another 2 we have as a parameterized constructor. We'll do that, right. So if we will have only 2 things, val and is leaf, then the rest of the data is null, right. If not, then we will have all the data over the things, right. Now what we will have, we have, let me zoom a little bit so that okay, so now as you can see here, let me, okay, okay, so now what we have here, two things we have, right. The first is grid we have given, and another, it is saying that we have to return the node, right. So what we will do, first of all, we should always see the input, right. So input is here, we have grid, right. So grid contains what, all the values, right. So to do that, what we will do, we will create one recursive function, right, and this recursive function will call the value, right. You can say recursive call will do. Okay, so what I will do, we will we'll call a return, and we'll call our recursive function. Let's see, I'll see recursive recursive solution, you can say, recursive construct, you can say, or solution, you can say. Okay, in the recursive solution, what we will do, pass recursive solution. Okay, so the recursive solution will take what, first we are passing the grid, right, and this this grid will take what, its x coordinate and y coordinate, right. So in the x coordinate, I'll take will start from 0, and y coordinate is also from 0, means origin will starting from, right. And then what we will do, we'll pass the grid length, so that we'll divide, if it's required length by 2 will do for all these 4 steps that we have talked talked about, right? So if this is our recursive solution, so it will return what? It will return our node value. So I'll take the node as a return type, and I'll pass this function name. And first what we will pass, I was talking about, we will pass the grid one, right? So first we are passing grid here, so we'll pass the grid. Next what we'll pass our x coordinate, so this is nothing but our x1, you can say x coordinate. And similarly we'll pass our int y coordinate, y1, and the length, that we are passing length of the grid, you can say. So I'll pass the length, right? Now what we will do, uh, we'll check if the leaf node have all the same value, right? You can say base condition, you can say. So let's create one base condition, base case. And base case saying that we'll check if, we'll check the value, right? So check uh, value, check value is same, is same, or is same value, you can say. Check value is same value in grid. Okay, so I'll pass this function, and this will take what, this we will pass the grid, and it will check based on its coordinate. We are passing x1, and we're passing what, y1. So if this will and the length you can also pass length. So if you are passing grid length, sorry, x coordinate, y coordinate, and if the grid contains you can say same values, so it will say true or false, right? If this is true, then what we will do, we will return our you can say node, right? We will not do anything if it is same. So we'll say let's return node, and it will contain what, the grid that we are talking about, the x1, and similarly we'll take y1. Okay, so the given grid we have to return, we will not do anything, and we'll say if equal to 1, right? Then we will return what, another, first we will pass the grid one, that is we'll say this is all are 1, right? And we'll say another value, we'll say the leaf value, that is a true, leaf are true, means that is last value, yes. Okay, if this is the case done, right, then what we will do, we'll say else condition, and in the else condition we'll pass we'll create the root, you can say, if value is not same, right? Now you can say node we have, and node will take what, this is our root node, and root node will take will, if we'll create the root node, right? So we have to take a root node as two things we have to pass. The first, the grid value, that is value is false, and you can say isLeaf is also false, right? So we'll pass isLeaf, and gridleaf is also false. Now what we will do, we'll do the recursive call for the 4 submatrices, and we'll check its values, right? Now do the recursive recursive call for 4 children, 4 child, right? So for how we'll do that, we'll do we have root, we have, right, we have just created root. So on the root we'll call our top left, right? Why it is not coming? Root dot, we have taken what node, it should come top left, is public method, right? So it should come top left. I'm passing, let's suppose top left, and then we'll pass what, our recursive function, this is our function, that same way we will call. Okay, here, so here what will change, the grid we have, right? X1, this is our x1, and this is our y1, right? And the length is what, previously we are passing length, this length by 2 will do like this, right? And similarly we'll call for another 3 submatrices, right? We'll pass another subtree matrices. So first we have top left, then we will use for top right and okay. So now we had what top left we have done. Now we'll do the top right, so it should come actually top right. And then for the top right, what we will do, we will pass grid, then we'll pass x1 and y1 plus we'll do length, right? Let's suppose we'll take this length, we'll do plus here in the y1, this one. Okay, similarly for the top so bottom left, you can say will pass bottom bottom left. So bottom left will take what, grid plus length by 2. I'll pass grid plus length by 2. And for the y1 we'll pass the y1 and length will remain same, right? Now if we'll talk about bottom right, let me go bottom bottom right. So bottom right will take grid length x1 plus you can say x1 plus length by 2 and then y1 plus length by 2 and the length by 2. Okay, finally this is done. Now what we will do, we will return our root. Okay, now we have not created this is same method, right? So what we will do, we'll create one is same method that will check its node value. Okay, so let's create here. Okay, so this method will return what, boolean. So we'll say is boolean, and here we'll pass two things. The first will pass our int grid, right? This is our grid, and the another thing we are taking what x1 and y1. So I'll pass int x1 similarly and pass int y1 here, and its length, right? Int length. Now what we will do, first we'll check all the values. So to check all the values, we'll pass in the matrix we are passing. So we'll take two loop, int I equal to 0, right? I int equal to 0, and this will go to I should be less than what, x1, right? And then plus the length, sorry, x1 plus length. Okay, so this is the length we have given, and then I plus plus. Okay, now similarly we'll pass for you can say y will pass here. Okay, and this is I, and this is our you can say j. Okay, I j will go to y1. Okay, and length j plus plus, and here we will check ij will going to, now we can check grid values. So if grid at what I and grid at j is not equal to grid x1 and y1, right? If it not equal to, we will return here return false. If it is equal, means we are completing our loop, right? And then we will return in the function as a true. Okay, so let me check what I'm doing here. First, what we have taken a recursive function. So this recursive function will take grid. Okay, we have to comma, and x1 we are passing, y1 we are passing, length we are passing, right? So we'll check is if the all the length, if all the values are same, right? So we'll check on the grid ij equal to grid x1 and y1. If it is not equal, then we'll return false, and we'll do what we will do, we'll check for its four submatrix children. Will do the same thing. We'll call this grid. The first top left will take x1 y1, and top right will take y1 plus length y2, and bottom left will take x1 plus length y bottom left will take x1 plus length by 2 and y1, and bottom right will take what, x1 plus length by 2 and y1 plus length by 2 will take. Okay, so let me compile this one. Okay, so what is the expectation value is not matching. Okay, so first what I will take in here, we have taken a recursive call, and this recursive call will take what, grid, then x value and y value and grid length. Now we are, if we'll talk about this recursive function, will take grid, x1 y1 and length, and then we'll check if the value is same, right? What we will do, we'll pass length x1 y1 and grid with the length, and we'll check if it is equal to, if grid at x1 and grid at y1 we have equal to 1, and then we'll return we'll do 1, we'll assign 1, and then we'll return true. If not, then we will do what, we'll take one root node, and we'll say the top left will do, top left we will pass grid x1 y1 and length by 2. Okay, top right we will do what, x1 will pass and y1 plus length by 2 will do, and for the bottom left, right, bottom left will take what, x1 plus length by 2 and y1, and this one remains same. And for this one bottom right, what we will do, we'll do recursive x1 plus length by 2 and y1 plus length by 2 will do, and we will return true. Okay, and finally what we will do, we will return the root here. Okay, once this is done, then what we will do, we'll check our value. So if the length will start from what, grid, okay, sorry, grid should start with x1, grid should start with x1, and this will go to the last length x1 plus length, right? And for similarly for j, it's also should start with y1, and it will go to this last length. I think this was our mistakes, so this will work. Yeah, let's submit this one. Okay, this is working. Okay, so if we'll talk about you can say the what we can say, if we'll talk about our complexity, right? So complexity, we can see here is that what we have, we are going two loop here. The first checking the value, we are taking two values, right? We are taking two loop, grid one, right? So better we will discuss let's discuss uh, on the board, right? So let's understand our you can say complexity, right? So before understanding the complexity, right, what we can see that the approaches, right, each time if the values are not same, we are going for all the four children, right? And these four children, for these four children we have already taken the four nodes, right? We are visiting four nodes, right? And what we are doing here is that we can see we are calling the recursive function, we are doing the recursive call, and we are calling each time, right? And the recursive call, what we are doing, we are creating a new node, right, each time, and we are checking the value, right? We are checking the value also, and while we are checking the value, we are going with two loops, right? We are going, right, and then we are checking the value here, correct? So if we'll talk about the complexity, right, what is happening here, after every level of the recursion, the original length of the matrix get reduced to half, right? We are doing L by 2 each time, right? L by 2 we are doing each time. So this implies that the size of the matrix will reduce down to 1 after log n iteration. So all each time we are doing what, log n times we are reducing, or these are the levels, right? We are going down each time, and at each of these log n iterations, right, what we will do, we will have our some number of recursive call for the current matrix size, or if the size is what, 8, then we are doing what, 4, then we are doing 2, like that we are doing, right? And then we are doing 1. Okay, so for example, initially we have one call for the size of matrix, that is, if we'll take the size of matrix is n cross n, right? Then what will happen, then we will have four recursive call, right? You can say 4 into n, right? We have four recursive call will be there. So this image represent how at each level the total number of iterations over the matrix cells remains same as n square, right, for the n square. And n square iteration at each of the log n levels makes up the time complexity to be O. If we will talk about the time complexity, it will become what? O n square n into n and then log n, because this is what n levels we have. For this we have n levels we have, right? So if we'll talk about, there is n cells, right? We are talking about n square cells, n into n cells is n square cell. Then what we will have? There will be 4 iteration. Now what will happen? Size will become n by 2, but recursive call is what? 4. So what we have to do? N 4 into n square by 4, correct? Because because size is n, right? Then we are doing n square, but now size is what? N by 2. So it will go n square by 2 square, that is n square by 4, right? If n by 2 will do, it will become what? N square by 4, right? And so it will become what? N square by 4. And now it is what? Nothing but this 4 will get cut. Now it will be what? N square. So this will become n square. Okay, now similarly if we'll go n by 4, that is 16 calls will be there. Again if we'll do the same calculation, it will become n square. So each time you can see, for each level we will have n square you can say iterations for each level of log n. So total is what? Log n we have, log n levels we have, right? And total iteration is what? N square. So if we'll do that representation, it will become O of n square into log n, correct? So this is the time complexity we can say. For space complexity, how many levels we are going? Log n levels we are going. So we can say space will be log n. This is our space complexity, and this is our time complexity. Okay, this is our TC, and this is our space complexity. Okay, so thank you guys. If you like this video, please hit subscribe so that you will get this more videos. So in the next part of this video, we'll see the another approach, that is we can say optimize operations will do, and we'll try to see the optimize recursion, right? Thank you so much guys. If you like this video, please hit subscribe and do the comment that you want the another approach. Then I will upload the another approach, the recursive approach. Okay, optimize recursive approach. Thank you so much guys.